All right, class. I'm sorry I couldn't be there today, but we're going to go with those guided notes that you either picked up today or got yesterday. This is just a continuation of what we did before the break, where we were talking about solutions, dilutions, serial dilutions, and concentrations. So, first, let's talk about what a solution is, right? That's your first blank to fill out. So, we should all know what a solution is. Uh, so a solution is a mixture of two or more substances, right? So homogeneous just means that they're the same or they dissolve within one another. So we'll talk about this again a little later, but examples of solutions would be salt water, sweet tea, jello, things like that. So to make up a solution, you have either a solute or a solvent. So a solute is a substance in a solution that is the smallest amount. So examples of these, and I would write these down, would be your salt. So examples, salt, sugar, and that is what you're going to be adding to make that solution. Then you have your solvent, right? Clear that ink off so you guys can see. A solvent is a substance in a solution that is present in the larger amounts. So some examples of this would be water and tea. You all know that says water. I don't know why my computer's been doing this. This is the fourth time I've recorded it, and I am not restarting. So, clear off that ink for you. Let's move on. So you can see here the example on the slideshow is you've got your Kool-Aid powder as your solute, and your solvent is your water. And when you add those together, you get Kool-Aid. You could also do this with Jello or sweet tea, anything that where you're adding to get something else at a desired concentration. So you cannot have a solution of things that aren't alike. So you can't put sand in water and have a solution. Your sand's going to eventually settle at the bottom. Your water is going to be at the top, right? Like in the ocean, you don't have sand all up in the water all the time. You have two separate things. Same thing with oil and water. So those would not be solutions. Those would be mixtures. Milk is also a mixture. A solution is going to be something that will either completely dissolve. So hydrochloric acid and water, sweet tea, so tea and sugar, water and sugar, and then you add some lemon in there and you get lemonade. Things like that are solutions. And that all comes down to solubility. And solubility is the ability for a solute to dissolve in a solvent, right? So there is salt is not soluble. Sand is not soluble in water. Salt is soluble in water. Sugar is soluble in water. Oil is not soluble in water. But hydrochloric acid is soluble in water. So on and so forth. So we are going to talk about dilutions, and that revolves in, right? These solutions that you are making, you can then dilute. And the first thing that we're going to talk about is just a simple dilution. And this is where 1 unit of a solute is combined with an appropriate volume of a solvent to achieve a desired concentration, right? Lots of big words. Let's break it down. You want something to be a certain concentration. So that is, you don't want your sweet tea too sweet. You don't want your Jello too liquidy. So you're going to make sure you have that right concentration. And then you have to add the appropriate amount of solute to the right amount of solvent, right? So how do we do this? How does this all come about? Well, we can either just randomly go at it, or we can do the math. We should all know the math. It's called a dilution factor. This is a little different than what you did last week, but this is really important to know. So a dilution factor is the total number of volume, like the total units of volume in which your material is dissolved. So there's an equation for this, right? Dilution factor equals volume final over volume initial. So I need y'all to write down this formula. I need you to like tattoo it on your forehead. Not really, but we're gonna do some practice problems, okay? So let's work this one out together. If you have 10 milliliters of salt and you add 90 milliliters of water, what is your dilution factor? So we all know the equation, right? Dilution factor equals volume final over volume initial. So what is our final volume? How do we find that? Well, you're going to take the two volumes that you're given and add them together in this case. So 90 plus 10. Make sure you always add your units. All right, so that equals volume final. Now, your volume initial is always going to be your solute. So in this case, your volume initial is going to be 10 milliliters. Okay? So then we just plug it into the equation. Volume final over volume initial. What does that equal? So your dilution factor is 10. So you box it, you move on. All right? Super simple. All right, let's do another one together. So if you have 50 milliliters of sugar and you add 50 milliliters of water, what is your dilution factor? All right, I'm gonna give you some time to do this on your own. Okay, so let's write out our equation. Volume final over volume initial. So what's our volume initial? So it doesn't matter which one we use here because they're both the same, but I'm going to go with sugar because that's going to be our solute. Then our volume final is going to be our solute plus our solvent, which is 100 milliliters. Right? Then we plug it in, volume final on the top. Equals a dilution factor of 2. Box it and move on. Right? Super simple. All right, one more. So if you have 25 milliliters of Jello mix and you add 50 milliliters of water, what is your dilution factor? So Let's write our equation. Now, let's figure out our volume initial. That's going to be your 25 for your solute. Now we need our volume final. We're going to add these two together. We've got 75 milliliters. Now we just plug it into our equation, right? So 75 divided by 25. Right? So your dilution factor is a factor of 3. You will get more practice with this after our guided notes. All right, so moving on from dilution factor. It's important to know what a dilution factor is, but we also need to know other things about concentrations and solutions. So this equation should look familiar. You are going to have this is how you find fixed volumes of specific concentrations of liquid reagents. So this could be anything. You'll use this a lot in chemistry, but we also use it, I use it in medicine. So an example of how I use it in real life is Lieutenant Dan used to take a medication, and it had to be diluted. So I knew that his medication was 1,000 milligrams per milliliter, but he only needed 0.001 milligrams per milliliter. So instead of doing all of this math, I had 1 ml of 1,000 milligrams per milliliter, and I did this math to figure out how much volume I would need of volume 2, and I would dilute it down until I got that volume, right? So you're incorporating this and serial dilutions, which we'll talk about tomorrow. So this is your concentration 1, so C1 times V1, volume 1, equals concentration 2 times volume 2. So your C1s and V1s is going to be your source solution. So what you have, what is in front of you before you dilute it, before you change it, before you do anything to it. C2V2 is going to be your new solution. So this is where you want to go. So these can be in whatever units we're working in. Eggs, candies, moles, which we talked about before. Moles mean nothing. It is just a unit of measurement. It's like a dozen. You don't need to know what the exact number is, just know that it is a unit of measurement. So they give you an example here and how to work it out. So an experiment requires a final concentration of 0.1 m molar of tris in a total volume of 2 ml vials. You have a 1 molar solution. How much stock solution will you need? So you write out your equation like I always tell you. Then you make your chart like we did with the other one. So C1, V1, C2, V2, right? So final concentration is always going to be your 2. That's going to be your concentration. 0.1 molars, don't ever forget those units, in a total volume of 2 ml. Volume 2 is going to be 2 ml. You have So that tells you it's a source solution, 1 molar. We are trying to figure out how much we will need. So that's our volume 1. Then we set it up like you see here, and we plug and chug, right? We do simple algebra, right? Let's do some practice problems. So Dean has 400 milliliters of 1 mole of sugar. He needs 0.2 moles of sugar. How much can he make? So let's write this out. C1, V1, C2, V2. So Dean has, that tells you that is what he has. So that's going to be your C1. Of 1 molar. Wow, I totally messed that up. Let me try this again. I make mistakes too. C1, V1, C2, V2. Wow, okay. So he has, this is what's going to be your initial or your 1. So he has 400 milliliters of that. So that's going to be your volume. Of 1 mole, which is your concentration. This is how much he needs. So this is where he's going, which is going to be his concentration 2. And then we need to know how much can he make. So your volume 2 is a question mark. So let's set this equation up. You've got 1 times 400 equals 0.2 times V2, right? So we do the math. 400 times 1 is 400. And you divide by 0.2. You're going to get a big number, which is 2,000 milliliters. Box your answer and move on. All right, let's do another one. So I'm going to let you read this. This is a little bit of a different one. Matt needs 1 bag of candy, 1 bag that has 30 grams of candy in it. Each candy is 4 grams. How many candies are in each bag? So let's do this equation together. Actually going to let y'all work it out first, and then we'll do it together. So we have our C1, V1, C2, V2. So he needs, so this is going to be your volume, 1 bag. Your volume is 1 bag. Not your volume, your concentration. Wow. Doing great. 1 bag. Your volume is going to be 30 grams of candy in it. Each candy is 4 grams. How many candies does he need? So you've got 4 times C1 equals 1 times 30. So you multiply 1 and 30 together, you get your 30 equals 4 C1. Then you divide by 4. and you get 7.5. Box your answer and move on. All right, I'm going to give you a second to read this one and write the answer out. All right, so Miley has 400 milliliters of 5 molar HCl and needs to make a solution of 0.1 molars HCl. How much solution can she make? So let's write out our chart. C1, V1, C2, V2. So she has, that's going to be your initial volume or your V1. This is going to be your initial concentration. She needs to make, they give you the solution, concentration, which is 0.1 moles. We need to know how much she can make, so that's going to be a question mark there. Let's set up this equation. So 5 times 400 equals 0.1 times V2. All right, so 400 times 5 is going to be 2,000. And we're going to divide by that 0.1. What we do to one side, we have to do to another. And you will get V2 equals 20,000 milliliters. Box your answer and move on. All right, last question. I'll let you read it and answer it, and then we'll go over it together. All right, so Bruce is wanting to make ice cream. He needs 600 milligrams of 2 moles of sugar. He currently has 6 moles. How much does he need to use for his ice cream? So let's write up our chart. So Bruce is wanting to make ice cream. This is what he needs. This is where we're going. V2 is going to equal 600 milligrams of 2 moles. That's your concentration. What he currently has is 6 moles. Your concentration 1 is going to be 6. You are looking for your volume 1. So let's write this equation out. 6 times V1 equals 2 moles times 600. So 600 times 2 is 12,000 equals 6. You're going to divide by 6. Divide by 6. You get 200 milligrams. It's going to be your answer. Box it and move on. All right, so on your note sheet, I want you to take 5 minutes and write a question that involves your C1, V1, C2, V2 equation. And then you're going to have someone try to solve it. After that, there is an assignment on Blackboard for you to do. I will see you tomorrow. I hope you have a great day.